Okay, let's begin. I hope you had a good break of the 4th of July weekend. We have only 3 weeks left, week 5, 6, and 7. And week 8 is just the final exam. So in week 5, you are studying a few more topics in trigonometry. So there are a few more formulas for double angle and half angles. And we also study the trigonometric equations. And in chapter 7, we will study a few applications of trigonometry. The first section is on the law of sines. So let me explain these sections one by one. The first section is the double angle and half angle formulas. So again, there are a lot of formulas in this section, but you don't have to memorize them all. You can just look them up, use them whenever they are necessary. So the double angle identities are basically used to find the values of trigonometric functions for double angles, 2 times an angle, using the single angle values, sine x and cosine x and so on. So let's try to see a few examples. So let me just pull up an example on whiteboard. Just consider this question. Find the value of, say, sine of 2x, given that sine x equals, let's say, 3/5, and x is an angle in, say, quadrant 2. Okay. So according to the formula, sine 2x is equal to 2 times sine x times cosine x. Okay, first write down the formula. Now what we need to compute this sine 2x value is these two, sine x value and cosine x value. So sine x value is given. That's right here, 3/5. But cosine x is not given, so you have to figure out the value of cosine x. And to do that, this information, the quadrant, can be used usefully. So quadrant 2 is here. And using A as TC, we notice that the second quadrant is the sine quadrant. So from this picture, we can see the sign of cosine x should be negative. So it's negative value of a fraction. And to get the fraction, we just draw the triangle again. So here's the angle. And from sine x value, you can complete that triangle, there's 3 sides. The sine x is opposite over hypotenuse. So 3 goes here, 5 goes here, the hypotenuse. And the third side is use the Pythagorean theorem. So a squared plus b squared equals c squared. The c is the hypotenuse, so 5 goes here. And you can say a equals 3, for example. And b is the unknown value, the bottom side. And solve this equation. B equals 25 minus 9, which is 16. So square root of 16 gives you 4. The 4 goes there. So we complete the triangle using the triangle. Cosine x is adjacent over hypotenuse, which is 4/5. So we get the cosine value using the quadrant picture and the triangle. Then use the double angle formula and get the answer. So multiply all the fractions. So 5 times 5 is 25. 2 times 3 times -4 is -24. And we get the final answer. So this is a typical kind of question you will see in this section for using the double angle identities. There are other types of questions also. They are just easy. Just watch the videos and try to answer the questions. Anyone have any questions? Right, let's move on to the half angle identities. In the lecture notes, I wrote also the power reducing identities. You can skip those. These are quite useful in some areas, but in this course, I'm going to skip this power reducing identities. So let's get to these half angle identities. Most likely, you're going to use these. You're going to use these 4. Okay. So these are used to find the sine, cosine, tangent values of half of an angle, say x. So the name half angle identities. On the right side of the formula, you will see the regular cosine x or sine x and so on. Okay, so we are using these cosine sine values to get those values of sine, cosine of half of an angle x. Okay. So I'm going to show you a couple of typical questions from this section. You see two examples in the slides. They are two typical examples. So in this first example, we are to find the exact value of the cosine, for example, of an angle, a special angle. And this 1 of 5 is not familiar with those types of angles. Typical are 30 degrees, 45 degrees, and 60 degrees. And some variants of those angles, like 210 degrees. So 1 of 5 is not so typical, but you see 1 of 5 is a half of 1 of 5 is a half of one of the special angle, right? If you double this, it's 210. So 1 of 5 is a half of 210 degrees. And 210 is one of the angles in the unit circle. So 210 is right here. And you can see cosine and sine x values for the angle. So this is negative square root of 3 over 2, comma negative 1/2. So cosine x is this and sine x is this. So using the cosine sine angle, sine values of 210 degrees, we can compute the value of cosine of the half angle 1 of 5. So the first step is to write down the formula. So let's go back to the formula back up here. Cosine of the half angle is either plus or minus of the square root of 1 plus cosine x over 2. So I didn't write the square root part right now, but the squared value goes like this. And the squared, I wrote the squared here with plus minus signs. So let's just work out the fraction part first. So it's 1 plus cosine of the double of this half angle, which is 210 over 2. So what you have to do here is to write down, instead of cosine value, write down the fraction. Okay, and from the unit circle, we get cosine to the 210 degrees. It's right here, negative square root 3 over 2. And this goes right there. And work out the fractions. So this is a fraction. So write down 1 in fraction form, which is 2 over 2. And write this in one fraction with this common denominator 2. We have 2 minus square root of 3 all over 2. And then over 2 again. So write down 2 in the fraction form. Then you can write this in the form of this times the reciprocal of the denominator, which should be 1 over 2. Then we simplify the fraction, and 2 times 2 gives you this 4. And times 1 just gives you this part. So we get that. And then the next step is to use the plus minus square root. So this number goes in here. And separate the two fractions. Then square root of 4 gives you 2. And square root of this expression gives you this number. Then the last step is to determine the sign. You have to pick a sign, either plus or minus. To do that, you have to draw this chart again. So ASTC. Now, to determine the sign of this number, we have to look at this angle 1 of 5. 1 of 5 is the second quadrant. And the cosine value of this 1 of 5 should be minus, because 1 of 5 is in the second quadrant, which is the sine quadrant. So we take the negative sign, drop the plus sign, and we get this final answer. Okay? Right. Any questions? Okay. The last type of example is when you are given a value, but not the specific angle. So if you're just given a ratio of, say, in this question, you're given the tangent ratio. Again, you have to draw a triangle and use the sine, cosine, tangent, the quadrants to determine the sign and go from that. So let me work this out in the whiteboard. So we have to find the cosine value using the tangent value. And the tangent, the angle is between 90 degrees and 180 degrees. What you're given is actually the quadrant where this x lies. Okay, so let me copy this problem over to the whiteboard. So this is the question. Now what you're given is tangent value of x. Notice that this is half angle, this is the regular angle, just x. And tangent x is negative 3 over 4. So let me copy it down here. Okay, 90 degrees and 180 degrees. So let's write down the formula. Tangent x equals, if I remember correctly, this is cosine x over negative sine x. Let's verify this quickly. Oh, wait a second. We need the cosine formula, sorry. So what we need is cosine x over 2 formula, which is plus or minus square root of 1 plus cosine x over 2. Okay, so let's work this out. This is plus or minus square root of 1 plus all over 2. Now we need this cosine x value. So it's supposed to be a fraction, but it could be plus or minus. We'll determine the sign using this angle here. So x is in the second quadrant, which is the sine quadrant. So we determined that cosine x should be of negative value. Next, we need a fraction, so draw a triangle. And tangent is opposite over adjacent. So 3 goes here, and 4 goes down here. And use the Pythagorean theorem, figure out that this hypotenuse should be 5. And cosine x is opposite over, cosine x is adjacent of our hypotenuse, so the fraction is 4 over 5. So notice here, I didn't write this, the sign down here in the quadrant. We'll use the sign for the quadrants here and the sign here. When you actually draw the triangle, we're not going to use the sign. So just the numbers 3 and 4 to complete the triangle. So just positive numbers go to the triangle. So that's the cosine value, negative 4 over 5. So let's continue to work out these fractions. So use the common fraction. 1 equals 5 over 5. We have negative 4 over 5. We have this denominator, 2. So 5 over 5 minus 4 over 5 is 1 over 5 over 2, and 2 equals 1 over 2. So that's 1 over 5 times 1 over 2. So that's 1 over 10. The final step is to determine this sign, plus or minus. So here you have to be careful. We're not going to use this again because this angle is for x. Okay, this is the angle x. But what we need here is, this is the value for cosine of x over 2. So let me change the color. So this sign is for this angle. Okay, so a lot of students can make a mistake here because they use this quadrant for x, but you actually have to the quadrant for x over 2. So what is x over 2? So x is between 90 and 180. So if you think about it, x over 2 should be between a half of 180 and a half of 90. So it gives you 45 and 90 degrees. So this x over 2 is actually in quadrant 1. All right? So this is x over 2 quadrant. So quadrant 1 is A, which means all functions are positive. So we take the positive sign for this angle, from the cosine value of this angle. So the final answer is then the positive value of square root of 1 over 10. Okay? All right, any questions? So that was the second type of the typical questions for the half angle formulas. So practice a few problems and get to know how to use these formulas. Okay, let's get to the second part, the trigonometry equations. So the basic idea of trigonometric equations is that we want to figure out the angle value from a ratio, right? So look at this example. This is a typical sine equation. So you are given this equation, and the question is to figure out this theta value, okay? You're given a ratio, all right? So one way to find out the angle is to use this unit circle, all right? And to look it up to find the angle. So this is one of the special values of sine. And as you know, in the unit circle, if you have x comma y, x corresponds to the cosine value, and y corresponds to the sine value. So to solve a sine equation, you have to look at the y coordinates. And if you want to solve a cosine equation, you have to look at the x value. So what this example tells you is to look up this number from the y coordinates. And you see two y coordinates, two numbers in the y coordinates here and here. And so two angles, 60 degrees and 120 degrees. So those are the two answers, right? Two answers. The unit circle gives you the angles between 0 and all the way to 360 degrees. So if the interval is given, you can just look them up. See this, and in the question, you see the interval is between 0 and 2 pi, which is 360 degrees. The question just lets you find solutions between these angles, which are just telling you, just use the unit circle. So look them up, you get two angles, 60 degrees and 120 degrees. Or in radians, you get these two. So that's how you get the answer. You just look them up, get the answer right away. Any questions? So this is one of the easy type of questions. Here is another question. So this is a linear type. The first thing to do is to convert this into the basic type. You want to have just a single sine function or cosine function or tangent, whichever it is. There's a single function on the left, move all the numbers to the other side, to the right side. So what you do is to subtract 1 from both sides first. Then 1 minus 1 gives you 0. So 2 cosine theta equals 0 minus 1. All right. We still have this number 2, so we get rid of it by dividing both sides by 2. So we isolate cosine theta only. And we have converted the equation to this basic type. Cosine function only and the number on the right side. And this is the result. After doing that, look up this number -1/2 from the unit circle. Say cosine is the x coordinate, so look it up, -1/2. So there are many numbers here, but if you look at the x coordinate, look up the number -1/2. It's right here, and the second number right here. So we have two angles, this and this. So 120 and 240, two solutions. Okay. So the question asks you to find the solutions between 0 and 360. So these two are the answers. Okay, if the question asks you to find the angles in radians, 2 pi, that's radian value. You answer using the radian values. And if the question asks you to find the solutions using degrees, you answer the angles in degrees. Okay? Any questions using these unit circles? Let me also talk about how to find the answers using a calculator. Sometimes, you know, let me use a whiteboard. Sometimes you won't have access to the unit circle, or the numbers given in the equation may not be one of the special numbers that's in the unit circle. So you should know how to use a calculator or so. Okay, so let me explain that. So here's a question. Suppose you're given this question. Sine theta equals 0.2175. So it's a random number, suppose you're given that. Okay, and you want to find an angle between 0 and 360 degrees. So this angle range is typical, and this is the easiest case. So here's what you're going to do. First thing to do is to locate two angles. Typically, a sine or cosine equation gives you two solutions, as we have seen in the previous examples today. So first thing is to notice that this number is a positive value. I'm using ASTC again. Locate two quadrants where sine value is positive. The first quadrant is all, which means all functions are positive, and that matches with this equation. Sine is positive, that's good. So one of the solutions should be here. And look at the second quadrant. The second quadrant, sine is positive, which matches with this equation, right? Sine equals a positive value. This is where the second solution is. And look at the third quadrant. Tangent is positive, which means sine should be negative, right? According to this equation, sine should be positive. It can't be negative. So the solution can't be here. Do you understand? In tangent quadrant, sine is negative. That contradicts this equation. Sine is positive, so it can't be, the solution can't be here. The first quadrant, cosine is positive, right? So cosine is positive, it can't be here. Two solutions should be here, first quadrant and second quadrant. So that's how we get two numbers. And the next thing is to use a calculator to get an angle. Use the inverse sine of the number we have seen before, 0.2175, 0.2175, and take the inverse sine. Now we get this 12.56 degrees. 12.56 degrees. So inverse sine value of this equals 12.56. So this is actually a reference angle. So the reference angle is the angle between the given angle and the x-axis. So this angle here is 12.56, and this here is 12.56. So from this angle, we can get the two angles, the first quadrant and second quadrant. The first quadrant angle, that's just the same as this. So that's 12.56. For the second quadrant angle, just think about it. In the second quadrant, this is what we want. Let's call this theta. And this angle here is 12.56. Notice that these two angles make 180 degrees. 180 degrees is the sum of the two angles, theta and 12.56. So solve this equation, theta equals 180 minus 12.56. And this should give you 167.44 degrees. So two solutions. This is one. This is the second solution. It's a little long. There are quite a few steps to solve trigonometric equations using the calculator, but this is necessary. These are necessary steps. So follow these steps and try to understand the process. And now let's talk about a little bit more of the trig equations. Now this is the kind where you have to solve for multiple angles. Here's, if you look at this, we have a cosine value of a multiple angle. This is a triple angle, 3 times x. Okay. And again, for this type of question, we have to take a few steps. The first step is to solve the equation as usual, as we have seen before, as usual, to solve the equation for 3x first. To solve the equation, this is one of the special angles. So use the unit circle. Use the unit circle to look up these numbers, square root of 2 over 2, or cosine, which represents the x coordinate. So square root of 2, one of them is here, and the other should be here. So we'll get 45 degrees from the first quadrant and 315 from the fourth quadrant. So for multiple angles, what you have to do is to use these two solutions together with these two solutions. We are going to use this expression. Okay, plus 360n. This represents multiple revolutions around the circle. So adding 360 to 45 plus 360 actually make it go to the same angle, right? 45 is here. If you add 360, it goes back here. That's when n equals 1. If n equals 2, that represents the second revolution. So if you're adding 360 twice, it still goes to the same angle, all right? This just represents multiple revolutions around the circle. They still give you the answers for the trigonometric equations. So for multiple angles, we need this step, okay? After doing that, we have to divide these two equations by the multiple 3. So divide both by 3. So divide 45 by 3, you get 15. Divide 360 by 3, you get 120. Do the same thing for the second solution, we get this. And then these two expressions actually generate multiple angles for various values of n, okay? So for these various values, if n equals 0, you get 15 degrees. If n equals 1, you get 15 plus 120 times 1, which gives you 135. So you can think about this way. Begin with 15 right here. To generate more angles, you just add 120 plus 120. If you want 35 plus 120 gives you the next angle. You keep adding. So you generate more and more solutions. If you want to go back, you subtract 120. Gives you negative 105. Do the same thing for 105 plus 120 is and minus 120 is generate a few angles. And the reason why we're doing this is because we want the angles between, back in the problem, between 0 and 360 degrees. And actually, when you generate the angles, there are multiple angles, more than 2 angles that goes in those ranges. All these belong to the interval from 0 to 360. So we take all of them, and after that, 375, this is too big, that's over 360, so we just get rid of it, negative angles, get rid of them, and then we take these 6 angles. So there are more steps involved for multiple angle trigonometry equations, but it's a necessary step, and that's how you do it. We are about to I'm using a free account for Zoom, so we have a 40-minute restriction. So the video will end soon, but I'm going to invite you again in a moment. Just check out your email in a moment. So we will start the next session in 5 minutes, okay? Do you have any questions, by the way? Okay, we'll start the first session here. Check out your inbox and email. We'll start the second session in 5 minutes, okay?